friends, this video on work, energy and power part 6 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos from part 1 to part 5 before going ahead with part 6. Now that we have discussed work, we will discuss energy. Now in energy, here we will discuss majorly two types of energy, that is kinetic energy and potential energy. So we will discuss each of them one by one. So for now, we will start with kinetic energy. So what is kinetic energy? Energy of a body by virtue of motion of the body. That means the energy that exists in a body due to its movement. If a body is moving, the energy which it possesses due to the virtue of its movement, that is called kinetic energy. Let us take the example of this boy who is walking. So he is in motion. Now the energy which he possesses because he is moving is nothing but kinetic energy. So it is also a scalar quantity. It is given by half mv square. Don't worry, we'll derive this formula in the next slide, where m is the mass of the body and v is the velocity of the body with which it is moving. SI unit of kinetic energy is the same as work, that is, it is joule. Okay, so this is all about the basics of kinetic energy. The energy by virtue of motion, scalar quantity, given by half mv square, where m is the mass and v is the velocity, and SI unit is joule. Now let us go ahead and try to derive the formula, that is, from where did we get this half mv square for kinetic energy. So let us consider that we have a ball of mass m, which is initially at rest. So let us suppose we have a ball of mass m and this is initially at rest. Now some force is applied on this ball, say a force F is applied on the ball, and the ball starts moving with some velocity, say v. Okay, so now let us use our kinematic equations knowledge to derive an expression for kinetic energy. Now from kinematics third equation, we know that v square is equal to u square plus 2as. Right? Now in this case, what did we see? The mass was initially at rest. After that, that means u was 0. Later it gained a velocity v, and let us suppose it traveled some distance, say d, with the velocity v. Right? So in this case, if we use this kinematic equations, what do we find? This v square will be equal to u is 0. So this will be 2 into a into d. Right? So from here we get a is equal to v square divided by 2 into d. So this would be the acceleration in terms of velocity and the displacement. Now, as per our Newton's second law, what is force? Force is nothing but mass into acceleration. So mass of the body, as we already mentioned, we considered that mass is m. So acceleration, what is acceleration here? It is v square by 2d, right? So the force is mv square divided by 2d. Now let us come back to work done. What did we study? Work done is nothing but force dot displacement, that is F dot S, which is nothing but Fs cos theta, where theta is nothing but the angle between force and displacement. In this case, we see that the force and displacement, they both act parallel, that is, they are along the same direction, because the force is applied in this direction and the ball also moves in this direction. So theta is nothing but 0. So cos 0 is 1. So this will be F into S. So what is F? F is mv square divided by 2d. And what is S? S is the displacement, and we consider the displacement as d. So this d cancels. So we get this as half mv square. So what is this? The work done in the case of a moving body, is nothing but the energy which is possessed by the body when it is moving. So we can say that the kinetic energy of this body is half mv square. Clear? Because in the very first slide we defined that energy is nothing but the capacity to do this work. So whatever is the value of work, here the work turned out to be mv square by 2. That means this is the work which is associated with a body which is moving with velocity v. So this is nothing but the energy possessed by the body, and since this energy is possessed by virtue of its motion, therefore it is termed as kinetic energy. So the kinetic energy is equal to half mv square. Let us look at some applications of kinetic energy in real life. We'll take the example of hydroelectricity generation in dams. All of you would have seen dams somewhere or the other. So do you know what is the purpose of the dams? It is basically used for generation of hydroelectricity. As the name suggests, hydro plus electricity. That means electricity generated from water. Electricity generated from water. But how is electricity generated from water? That is what I'll explain you here. In this case, what happens is the dams are constructed in order to accumulate large amount of flowing water, so that the waters are accumulated here at high speed. Now when this water flowing at high speed, they fall on the turbines, they make the turbines rotate somewhat like this. I'll show you an experiment diagram which will make it clear. Let us suppose this is the water which is coming at huge speed. So when this water falls on a turbine, which is a wheel kind of a structure, what happens? Due to the motion of this water, this turbine starts rotating. Right? If you just imagine it this way, if something at very high speed falls on this turbine, it will come down. So the next one will again come down and this will start rotating in this direction. Now this turbine in turn is connected to a generator. As the turbine rotates, the generator also rotates, and as a result, electricity is generated. So what happens here is the flowing water has kinetic energy, right? So the kinetic energy of the water is utilized to generate electricity. So this flowing water which has kinetic energy, it rotates the turbine. The turbine in turn rotates the generator, and this generator in turn produces electricity. Right, so we see that this kinetic energy of water has a practical application in our daily life in generation of electricity. So you also understood why dams are constructed. Dams are constructed so that huge amount of water gets accumulated, which will come down at a very high velocity, because the higher the velocity of the water, the higher will be the speed of the rotation of the turbine, and in turn the generator will also be rotated and thus electricity will be generated. So that is how kinetic energy is useful in generation of electricity. We can also take another example of application of kinetic energy, which we normally see in a sailing ship. What happens in this case is, you would have seen that when the ship sails, there is a huge wind which keeps blowing. The blowing wind has nothing but kinetic energy. As I told you, anything in motion will have kinetic energy. So even the blowing wind has kinetic energy. And this blowing wind directs the ship in its direction when it is in the midst of the ocean. So thus the blowing wind's kinetic energy is utilized in sailing the ship. Right, so these are the certain applications of kinetic energy which we come across in our day-to-day life. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.